Here are two identical pans. One pan contains 200 grams of water. The other 400 grams. Everything is at room temperature. The pans are placed over identical gas hobs. Which pan of water will boil first? Obviously the one with less water. The pan with more water needs more energy for its temperature to change by a given amount. Its heat capacity is higher. So heat capacity depends on mass, but does it also depend on the substance being heated? Compare the heat capacity of cooking oil with water. Each pan contains 200 grams. Water on the left, oil on the right. As the pans are heated, the oil temperature increases rapidly. When the water starts boiling at 100 degrees Celsius, the oil temperature has reached over 130 degrees. For a given temperature rise, the oil needs less heat energy than water. We say that oil has a lower specific heat capacity than water. The specific heat capacity of a substance is given by the heat equation. Q is heat energy added to the substance. M is the mass of the substance. C, its specific heat capacity. T1, the initial temperature. T2, the final temperature. So T2 minus T1 is the change in temperature. Rearrange this equation to make C the subject. For example, let's find the specific heat capacity of aluminium. This cylinder is a 1 kilogram block of aluminium. Place an electric immersion heater in one hole and a thermometer in the other hole. Note the initial temperature T1, 27 degrees Celsius. Connect the heater to an electricity supply and switch on. After 20 minutes, switch off and note the highest temperature reached, T2, 37 degrees Celsius. We know the mass m equals 1 kilogram. And from our experiment, the temperature difference is 37 minus 27 equals 10 degrees. So these figures complete the bottom line. Now the energy added, Q. Assuming that all the heat supplied by the heater is received by the aluminium, Q equals VIT, where V is the voltage of the immersion heater, 5 volts, I is the current, 1.85 amps, and T is the time the heater was on. 20 minutes equals 1200 seconds. So multiplying these together gives Q equals 11,100 joules. Finally, substitute this value into the heat equation, and our calculated specific heat capacity is 1,110. The units are joules per kilogram per degree Celsius. The actual value for the specific heat capacity of aluminium is 908. So our experimental value was quite close. Can you suggest causes of error and improvements to our experiment?